Okay, this video is a polynomial review. Things you've already known, you've done before. Just want to refresh your memory as we walk into the next section of our trig study. Alright, so first, let's just remind ourselves how to multiply binomials. Binomial is called a binomial because there's two factors, okay? Or two terms, I should say. It's a binomial times a binomial. So you may have learned box method, you may have learned FOIL, you may have learned Miftarm like I taught you. Whatever method works for you is fine with me. You just have to be able to factor and multiply both ways. Okay, Miftarm is more factoring, not multiplying. So if you use box or FOIL, I use FOIL, so I'm going to just do that. First terms multiplied, I get x squared. Outer terms multiplied, I get negative 7x. Inner terms, 3x. Last terms, negative 21. Then you combine like terms, so I get x squared minus 4x minus 21, and that is my answer. That's as far as I can take it. Example 2, x minus 2 squared. Now, it is not x squared plus 4. That does not work. That is breaking all mathematical laws. What this is really is x minus 2 times x minus 2. And then you would use box or FOIL, whatever method you want. First terms is x squared, outer minus 2x, inner minus 2x, last plus 4. So again, I can combine my middle terms to minus 4x plus 4. Alright, there it is. Last example, x plus 5, x minus 5. So notice that the first terms are exactly the same, last terms are exactly the same. What's different is that one's a plus, one's a minus. So this is what you call a difference of squares, and we'll talk more about this in a moment. But this is what it looks like factored out. When you multiply it, box or FOIL, you'll get x squared minus 5x plus 5x minus 25. The beauty of a difference of squares is the middle two terms cancel each other out. And what you're left with is x squared minus 25. So you can look at this and say, well, x squared is just x times x, and 25 is just 5 times 5. And then the minus between became as a result of the positive times the negative. We'll talk about this more in a moment, like I said. Alright, next thing I want to remind you about is adding and subtract rational function or rational equations. Now, rationals means fractions, means you got something in the bottom, something in the top. And usually x is in the bottom if it's a rational. So, how do you do this? Well, it's just like any old fraction. You have to have a common denominator. So, what is my least common denominator between these two? Well, it's going to have to be the x plus 1 times x plus 4. That whole thing is my least common denominator. But in order to get there, I have to multiply to get that common denominator. So my common denominator is going to be x plus 1 times x plus 4. Alright, but to get there, I have to multiply the 3 times x plus 4 minus, because there's a minus sign between, the 2, and the 2 has to be multiplied by the x plus 1 in order to get the common denominator. Then I distribute and reduce. So I have 3x plus 12, distribute the negative 2, minus 2x minus 2. Bottom, I'm going to FOIL it, x squared plus 4x plus x plus 4. And lastly, I need to reduce this. So 3x minus 2x is x. 12 minus 2 is 10 over x squared plus 5x plus 4. That is my reduced answer. Okay? That is how you subtracted rationals. Okay, on example 5, again, I need to subtract rationals. Now notice this is x squared and this is just an x. So what I would do first is factor this. Hopefully you recognize this as the difference of squares, but in case you don't, if you use use box or FOIL or Miftarm, whatever, to factor it. If I do that, Miftarm says multiply a times c, so that's negative 49. What two terms multiply to negative 49 but add to a 0 for b? Remember, 0 is the middle term. 7 and a negative 7. Divide by a, which is 1. X in the bottom, read them up. So I get x plus 7, x minus 7. That is a difference of squares. So when I see it in factored form, this term over here is not all that different. All it is it's just missing the x plus 7 term. So all this is right here is my least common multiple, or least common denominator that I need for both fractions. So in order to achieve that, I need to multiply this guy over here by x plus 7 over x plus 7. And then they'll have the same denominator. So if I do that, I'll have x squared minus 49 on the bottom. On top, I'm going to have 1 plus 1 times x plus 7. And then I just distribute and reduce 1 plus x plus 7 over x squared minus 49. So it's x plus 8 over x squared minus 49. All right. You've got to be able to know how to get common denominators, even using binomials in rationals. Please come in and get help if you're having a hard time with that. It's very important you know that as we walk into the identity section. All right, factoring. Pure factoring. First one here is just factoring out what is in common. All right. Greatest common factor, you may have been taught. What is the greatest common factor between these two? Well, you can take a 3 out. This is x squared and this is an x, so the most x's I can take out of both is 1. Both of them have one y, so I can take a y. So I can take out that greatest common factor, and what's left is what would be left if I reduced it like this, if I divide it. That would cancel, that would cancel. X squared divided by x leaves me with x. Same thing here, if I divide it by 3xy, what would happen? 18 divided by 3 is 6. X's cancel, y's cancel, so that's all that's left. And that's all I can do here. I was just factoring out a greatest common factor in this one. Example 7. You have a trinomial. You need to factor it into 2 binomials. Use box or FOIL or MIFTARM, whatever floats your boat. You've got to be able to do it. So let's look at this. MIFTARM says multiply a times c, and I get negative 20. And I need 2 terms that are going to multiply to give me negative 20, but add to give me negative 8. Well, of course you think 5 and 4, but that doesn't get us to 8. What about 2 times 10? It's negative 2 and positive 2 and a negative 10. They will add to a negative 8. Divide by a, which is 1. Put x in the bottom. Read them up. So my 2 factors are x plus 2, x minus 10. There it is, factored out. Last example. This is not a trinomial. It's 2 terms, but it's still x squared. So if you see an x squared and there's only 2 terms, look and see if there's a minus. If there's a minus, then it might be a difference of squares. Look at this last term. If it's a perfect square, then it is a difference of squares. What's the square root of 16? Well, it's a 4. So, square root of x squared is just x. Square root of 16, you just said, is 4. And the minus, to get the minus in the middle, one has to be a positive, one has to be a negative. And that's what a difference of squares looks like factored. Hopefully you will get to where you recognize those and won't have to think a whole lot about them, but you'll be able to quickly factor those. All right, for the whisk, I want you to factor this one on your own, and you'll be putting in those factors for me on the whisk. See you in class tomorrow.